A formula is an algebraic equation that relates two or more real-life quantities. For example, if you look here, we have our area formula. Area equals length times width. What we're going to be working on in this lesson is we want to take our formulas and solve for different variables. What I mean is right now this is solved for area, but when it says solve A equals L times W, area equals length times width, for W, what that means is we want it to say W equals something. So, even though we're dealing with variables, we still follow our steps for solving equations. What are we solving for? W. What do we need to get rid of? This L. How do we get rid of it? Well, since it's L times W, we divide. And whatever we do to one side, we do to the other. What you'll notice is that our W's cancel out, our L's cancel out, and we're left with W equals just A over L. If I write it a little bit better over here, width equals area divided by length. What that allows us to do is take some word problems, real life problems, and solve them easier. It says find the width of a rectangle that has an area of 42 square feet and a length of 6 feet. So if we use our formula now, width equals area divided by length, we can just plug in what we know. We know our area is 42 and our length is 6. 42 divided by 6 would be 7. So our width is going to be 7 feet. Again, all that allows us to do by changing this formula is to solve our real life problem a lot easier. Let's look at another example. This one looks a little bit more complicated. It says solve K equals 5/9 times the quantity F minus 32 plus 273 for F. Now this just basically says Kelvin temperature equals 5/9 times the quantity Fahrenheit temperature minus 32 plus 273. Okay? When it says for F, we want it to be F equals. So start by writing down your equation, and then piece by piece try to work on getting that F by itself. Okay? So again, what are we solving for? Well, ultimately we want F by itself. So what do we have to get rid of? Well, we're going to have to get rid of a 5/9, and we're going to have to get rid of a 32, and we're going to have to get rid of 273. What should we do first? Remember, always try to get rid of whatever's being added or subtracted on first. So what that means is I'm going to subtract this 273 from each side. Again, just following our rules for solving equations, even though we're working with two variables right now. We can't subtract this, but we can write this as K minus 273 equals what we're left with on this side, 5/9 times the quantity F minus 32, and this cancels out. Okay, so now we've gotten rid of one number. Let's try to get rid of another one. This F minus 32 is in parentheses, so that's 5/9 times that. We could use the distributive property here, but it's probably easier just to try to get rid of that 5/9. I didn't leave myself a lot of room here, but to get rid of 5/9, remember, this is being multiplied by 5/9. To get rid of it, we could divide by 5/9. But remember, dividing by 5/9 is the same thing as multiplying by 9/5. And whatever we do to one side, do to the other. So we're going to take this whole quantity on the other side and multiply it by 9/5. Okay. These cancel out, so we're left with 9/5, just leave it, times the quantity K minus 273 equal to, now what's left on this side? Fahrenheit minus 32. Almost there. We have our F here we want to solve for. Now we just have to get rid of the 32. Since it's minus 32, add 32 to each side. It does look a little weird here on the left side, but there's nothing we can do. Remember, the formula was kind of weird looking to begin with. So we can just leave this as 9/5 times the quantity K minus 273 plus 32. And that has to equal our Fahrenheit. We can't really combine like terms or anything here. You could use the distributive property, but then you're going to be dealing with a whole bunch of fractions, so you don't have to do that. Okay, you can just leave it as Fahrenheit temperature equals 9/5 times the quantity Kelvin temperature minus 273 plus 32. Now if I was given the Kelvin temperature, I'd just plug it in and be able to solve. Let's look at an interest problem. Notice this one says solve interest equals principal times rate times time for t. So again, we want t equals. So we take our interest equals principal times rate times time. We want to get time by itself, so we have to get rid of the principal and the rate. Now you could go through and divide both sides by p, and then that cancels out and you're left with RT and divide by R then. Or you could just think of this as being one quantity and divide right away by P times R. Okay. Again, this will cancel this out. We're left with T equals just the interest divided by principal times rate. T equals our interest divided by the principal times the rate. Now if you look at this example, it says find the number of years T that $2,800 was invested to earn 504 at 4.5%. So if you have your formula of T equals interest over principal times rate, now we can plug in what we know. Our interest earned was 504. The principal, that's the amount we put in or take out of an account, is 2,800 times our rate. Please remember that our rate needs to be written as a decimal, 0.045. If you type that into a calculator, please be careful, because if you just type in 504 divided by 2,800 times 0.045, it's going to divide this first and then multiply. So take your 504 and do 2,800 times 0.045, which is 12.6, and then divide. And you should get 40 years it would take, which doesn't make sense, so I made a mistake somewhere. Perhaps I divided wrong. Sorry guys. That's why we always check to make sure our answers make sense. When we multiply 2,800 by 0.045, not 0.45, you get 126. So if you go 504 divided by 126, now our answer makes sense. It's going to be 4 years. Okay, so again, I apologize for typing it in wrong into my calculator. But it's going to take 4 years to earn $504 at a really good percentage rate of 4.5%. When we're solving formulas for a different variable, you guys, just use your steps for solving equations. They're the same.